Hello dear students, welcome to GDC classes English. So in this series we are going to see the model papers which is regarding Telangana Pharmacist Examination. So in today's session we are going to see 20 important MCQ which is related to the pharmaceutic subjects. So let's get started with the first MCQ. So the first MCQ is pharmacy education in India as a university level program started in 1937 at. So we have to identify in which university the pharmacy education was first started in 1937. Option A is Delhi University. Option B is University of Madras. Option C is Banaras Hindu University, that is BHU. And option D is Patna University. So the very first time it was started in Banaras Hindu University in the year 1937. So Banaras Hindu University. So in India, formal pharmacy education leading to a degree began with introduction of 3 years Bachelor of Pharmacy. So initially it was a course of 3 years and it was started at Banaras Hindu University in the year 1937. So the second one is identify the correct spelling. So the spelling is regarding the pharmacopoeia. Although we pronounce it as pharmacopoeia, but the spelling is different. So first is it is given as starting with F. So we know that although we pronounce it as pharmacopoeia, but it does not start with the letter F. So option A is not the right answer. Next is pharmacopoeia. Now, although we pronounce it as pharmacopoeia, but the actual spelling is poeia. It is like P-O-E-I-E. So option B is the right answer. Let's see what is option C. So in option C, it is different. It is pharmacopoeia. So that is not the correct option. And next is pharmacopoeia. Here I is missing. So the correct spelling of pharmacopoeia, it is nothing but option B. So basically what is pharmacopoeia? So it is derived from two words. So first is pharmakon. Pharmakon is nothing but the drug and poeia means make. So basically pharmacopoeia, it is a book which contains the information particular to that drug. So it is a book describing drugs, chemicals, any medicinal preparations, especially one issued by an officially recognized authority and serving as a standard. So depending upon that, we have different pharmacopoeia, Indian pharmacopoeia, British pharmacopoeia, USP. So these are the different pharmacopoeias where we can get the information regarding drug, medicinal substance or any other chemical substance. Third one is Martindale. Martindale, it is an extra pharmacopoeia. It comes under pharmacopoeia, but that is the extra pharmacopoeia. It was first published in which year? So option A is 1886. Option B is 2003. Option C is 1883. Option D is 2006. So Martindale was first published in which year? So it was published in the year 1883. So option C is the right answer. So let's see what are the different years and the edition and in which year, what is the significance that what is launched in that year. So first is 1820. So USP first edition. So it was launched by United States Pharmacopoeial Convention. So that was started in 1820. Remember this one. Then we have 1883. So this was the question they have asked, like Martindale first published in which year? So that is 1883. And it was launched by William Martindale. Because of this name, it came as Martindale. Then we have certain national formulary. So in 1960, the first edition of national formulary, so that was launched by Government of India, Ministry of Health. Then we have the second edition after 6 years, that is launched by Dr. B.B. Yodh. So at that time, he was the chairman for the second edition of national formulary. Then in 1979, we have third edition of national formulary and that was launched by Dr. Vic K.L. So at that time, Dr. Vic K.L. was the chairman during the launch of third edition of national formulary. Then in 2011, fourth edition, Sri K. Chandramouli. Sri K. Chandramouli. So it was launched by Sri K. Chandramouli. Then in 2006, the fifth edition came and it was launched by Ministry of Health and Family Welfare under Government of India. And the recent one is about the 2021 sixth edition, that is Mansukh Mandviya. So remember the latest and the first, basically the first when it was launched, and which is the latest edition. So the latest is in 2021, and that is the sixth edition, and it was launched by Mansukh Mandviya. The fourth MCQ, the pharmaceutical aid used as excipient in tablet and pills. So can you tell me what is the correct option for this one? So basically pharmaceutical aid, so that will act as your, if it is tablet and pills means either it will be diluent, it can be lubricant, any of them. So we have to identify which of the pharmaceutical excipient among the four options it is present in the tablets and pills. So option A is olive oil. So basically we are not using any oils because they have given a specific dosage form. If it is soft gelatin capsule, definitely we can think of that. But for tablet and pills, we are not using olive oil. Kaolin, lanolin and beeswax. So yes, kaolin we are using. Kaolin, it is used as diluent in tablets and pills. Lanolin, beeswax, so these are used in the semi-solid dosage forms. So kaolin is used as a diluent in tablets and pills. So what is kaolin? It is a white clay. It is a clay-like structure, and basically whenever we are using this diluent, they has to be inert, they has to be non-reactive with the API, and of course it has to be inert without any stability issues. So it is used as an excipient in tablets. It serves as a diluent or filler, increasing the bulk of the tablet. So filler means, for example, if any tablet which is having the dose of 0.5 mg. So it is very difficult to handle these small tablets. To increase the bulk, we are adding certain diluents. So kaolin is one of the diluent which is added as a filler or as a diluent in the tablet. Kaolin is inert and does not react with other tablet ingredients and also with the API. API is nothing but active pharmaceutical ingredient. Its fine particle size helps to improve the tablet hardness and disintegration. If the size is less, definitely it will improve the hardness, it will improve the disintegration of the tablet, which is required for the dissolution process. Additionally, it also acts as binder in some formulation. Binder means what? Whenever you are using, for example, wet granulation technique, so in that case, it helps to bind the tablet ingredients together so that it will not separate after compression. So that is a binding nature. So kaolin has different roles. It acts as binder also, it acts as diluent also. Next is antioxidants are except. That means in all of the option, three options are antioxidant except one. So we have to identify. So vitamin C act as antioxidant. Yes, vitamin C act as antioxidant. Antioxidant means those which will prevent the process of oxidation. They will prevent the process of oxidation. So vitamin C act as antioxidant, and generally these ingredients are added when you have oil in your formulation, and if this oil is susceptible to oxidation, we will add certain antioxidant. Lycopene, yes, lycopene is added. Thiomersal, we will not add thiomersal as antioxidant, but carotenoids is added as antioxidant. So these are the some categories of the compound which act as antioxidant. So carotenoids, it is obtained from carrots, citrus fruit, sweet potato. These are the natural sources. Catechins, it is obtained from green tea, berries, oil seeds. Lycopene, it is obtained from tomatoes, papaya, watermelon. Phenolic acid, it is obtained from cereals and certain gums. And vitamin C, we know that it is a water soluble vitamin, and it is present in certain fruits, vegetables and the berries. Like citrus fruit also contains this vitamin C. So these are the different examples of antioxidant. Which of the following is not a preservative? Okay, so these all options are given. The first one is EDTA, that is ethylene diamine tetraacetic acid. This is nothing but ethylene diamine tetraacetic acid. So that is EDTA. Next is vitamin E. Next is phenol. Vitamin E is also known as tocopherol. Vitamin E is nothing but tocopherol. Then phenol. And D is cardamom flavor. So in this one, EDTA act as your preservative. Yes, EDTA act as preservative. Vitamin E, that is tocopherol, that also act as preservative. Phenol also act as preservative. Cardamom flavor, the name itself suggests it is not a preservative, it is a flavoring agent. Okay, so option D is the right answer, which is not a preservative. So this is the classification of preservative. The first one is based on the mechanism of action, like how the preservatives will act, whether they are antioxidants like vitamin C, vitamin E. BHA is nothing but butylated hydroxyanisole. BHT is nothing but butylated hydroxytoluene, and next is propyl gallate. Next is antimicrobial agent. So they will kill the microorganism. So benzoic acid, parabens, then we have alkyl acids and the phenols. So these are the antimicrobial. Chelating agent, chelating means they will form some bond-like structure. So EDTA and citric acid. Next is based on the source, like how it is obtained. So first is the natural source, like salt, lemon, and synthetic like benzoates, sorbates, propionates. So this is the classification of preservative. Seventh is which of the following meal works on the principle of combined impact and attrition. Now what is impact? Impact is nothing but, for example, one surface will be there. First is milling. Milling is nothing but size reduction. Okay, so there has to be certain principle how the size reduction will happen. For example, impact is nothing but one surface will be there. If your particle is striking to that surface, a strong surface, we call it as impact. If the particle is striking to that surface and if it is breaking to certain particles, we call it as impact. So that is nothing but it will lead to size reduction. What do you mean by attrition? Attrition means when two surfaces colloid with each other, leading to size reduction. Two surfaces colloiding with each other lead to size reduction. We call it as attrition. So there are different mills like hammer mill, ball mill, roller mill, and disintegrator mill. So in this one, which act on the principle of impact? That means impact will also be there, attrition will also be there. So the correct option is option B, that is ball mill, because what happened? For example, this is the surface of the machine and inside you will have certain balls, and these balls will be of different sizes. So you will pour your like particles here. If the particle is striking to this wall, it is known as impact. And when you will rotate the ball mill, at that time balls will also colloid over each other. They will also collide with each other. So here it will happen attrition. So we call it as the principle of impact and attrition. So it works on the principle of impact and attrition. So see here it is given, when it is colliding here, it causes impact, and when the balls are rolling over each other, we call it as attrition. So impact occurs due to corrosion between rapidly moving balls and the powder material. Here it will happen. And attrition occurs. Now here that surface will be the ball surface. In the impact, which I told you earlier. Now in this case, ball surface will act as a one stationary one, and here your powder which is colloiding, that will have an impact. And when they will roll over each other, particles and the balls with the surface of the mill, that is nothing but attrition. So in this case, both the mechanism happens. Next is size separation is not based on one of the following properties. Size, whenever you are having a powder material which is having different sizes, so in that case, whenever size separation happen, that is based on certain principle. Now what is that principle? It can be like based upon the density. For example, if we separate the particles based on density, the higher dense particles and lower density particles will be separated. Then based on shape also you can separate, like how is the texture, whether it is round balls, whether they are having groove like structure. Or you can also separate based upon size. Sieving method is there, but we cannot separate based on the particle texture, right? So particle density, yes, we can separate. Particle shape also we can separate. Particle texture we cannot, and particle size we can separate. So these are the different properties based on which the size separation can occur. So it involves separating a mixture of particles of different sizes into two or more portions using a screening surface. That screening surface can be like your sieve. So this will help to separate the sizes of the particle, different sizes of the particle. So it can be based upon size, it can be based upon shape, density between the particle, and for this it is used. Homogenizer are used for homogenization. The name itself suggests homogenizers means whenever the two phases are there. For example, in case of emulsion, you have oil phase and you have water phase. You know that these together cannot be mixed together. These two cannot be mixed together. So that is the reason we need certain homogenizers to mix it, right? Yes, you will definitely add some surfactant, but the process is for the mixing. So we are not using homogenizers for size separation, filtration, no, maceration, mixing. So basically we are using it for the mixing purpose. So you will have like shaft like structure here, like this shaft will be there in which at certain RPM this will rotate. It can go from 8,000, 10,000 depending upon the type of homogenizer, and it will help to mix the oil and the aqueous phase containing surfactant. So they are kind of mixers. It is for the liquid. Okay, in the solid also we have certain mixers. V cone blenders are there, double cone are there. So in case of homogenizers, they are used to emulsify, disperse or dissolve liquid or sometimes solid in liquid like suspension, and they are using certain mechanical force. Homogenizers are industrial benchtop laboratory instruments that are utilized in industry level also and in the study, that is academic level also. The mixing and dissolution of different materials like particles, pigments, chemicals, food, cells, tissues. So homogenizers can be used not only for pharmaceutical but other purpose as well. For what purpose are sintered glass fibers commonly used? So basically, sintered glass, we are using glass fibers for the sterilization process. So, but in that also we are removing some bacterial filtration we are doing of the parenteral products. Okay, it is not for all. So specifically for parenteral product it is done. So sterilization of pharmaceutical products, as I said, not for all. Filtration, it is not done. Bacterial filtration of parenteral products and filtration of solids. So option C is the right answer. These are useful for sterilization of wide variety of pharmaceutical products like potent drugs, corrosive liquids, oxidizing agent, and they are also used for the bacterial filtration of pharmaceutical products, and sometimes some if viscous syrups, viscous liquids like syrups, oils, etc. they can be used. What is drying? Now everybody knows that drying means any solvent or the moisture removing from the solid material, that is nothing but drying. So we are not adding moisture in the process of drying. Separating solid and liquid, no. Removing moisture from solid by thermal vaporization. Thermal means we are using certain temperature. Okay, and none of this. Okay, so C is the right answer. So it is the final removal of moisture from solid by thermal vaporization. So there are different dryers, tray dryer. So like this, different equipments are there in which we are using to dry the product. And it is generally to prevent the product more soluble and to prevent deterioration of the product. So if the product is not stable in that moisture condition, so it is better to remove the moisture, because if moisture is present, definitely there are chances of microbial growth. So it's better to remove. For that process we are using different dryers. 12th MCQ is, what are additional objectives of drying tablet granules? First is increase moisture content and bulk. If we are drying, definitely moisture content will not increase. Moisture content has to decrease. If moisture content is decreased, bulk will also decrease, right? So option A is not the right answer. Enhance tablet taste and color. There is no relation between drying and enhancing the taste and odor. So option B is not the right answer. Option C is reduce moisture. Yes, drying will reduce the moisture. If moisture is reduced, the bulk will also reduce. and it will prevent deterioration during storage. Yes, if there is no moisture present, there are no chances of microbial contamination. Definitely the product will be more stable. Okay, so option C is right answer. Let's see what is option D. Improve tablet solubility and dissolution rate. Tablet solubility and the dissolution rate depends upon what excipient you are using, what are the physico-chemical properties of the API, right? If it is soluble, definitely it will get soluble. If you are using certain surfactant, it will affect your solubility and dissolution. So it has nothing to do with the drying of tablet granules. So option C is right answer. So objectives are to understand drying development related to chemical, physical stability, drying kinetics and powder properties. To encourage further fundamental research and technological advancement for improving the drying process. Then other objectives are to carry out size reduction, then to avoid degradation on storage, dry the tablet granules, reduce the moisture and reduce the bulk. So not only for the drying purpose, but overall, once the drying happens, these are the different objectives that we can achieve. So drying is important, but at the same time we have to do controlled drying. If you do over drying, again there are different defects that can happen, like cracking, breaking, like that. The agent which helps powder fuse or link particles to one another in tablet. Fuse or that will help to make them together, that is nothing but your binder. As we discussed, the binder will help to fuse the particles. It will help to make sure that the particles are together even after compression. It is not like it will separate. So for that reason, binders are added. Fillers will make up the required bulk of the tablet. Okay, so this is not related to sticking of the particles together. Additives are your, like for example, lubricants, glidants. So they improve the flow. They improve the flow property. They reduce the friction. And the lubricants, as I said, lubricants will reduce the friction between the particles and the machine. So A is the right answer. Diluents they will use to increase the bulk, or they will act as a filler. If your dose is not sufficient, then you require certain bulk to improve that one. Then we have binders and adhesive. So binding agents are used to increase the cohesion. Cohesion means what? The force of attraction between similar molecules. Force of attraction between similar molecule. If it is adhesion, that means that is a different molecules. It will lead to improved hardness and friability. Okay, so your hardness will improve, your friability will improve, right? So if particles are together, then they will not lead to decrease in the weight after the friability. So used to provide cohesive qualities. More the binder, harder the tablet, but your hardness should also be in the limit, because if you increase more binder, it will affect your disintegration also. So in that case we have to be careful. Disintegrants. Disintegrant means what? Whenever a patient will take a tablet, so we have to ensure that tablet will break up easily in the gastrointestinal fluid. Okay, so to facilitate the breakup of the tablet in the gastrointestinal fluid, we are adding disintegrants. Lubricant, it will reduce the friction during your compression with the machine. So between wall of the tablet and wall of the die during tablet ejection, from where your tablet will eject. It should eject smoothly without causing any of the breakage or something. So to facilitate easy removal of the tablet from the die, lubricants we are adding. Adherent, anti-adherents, it will prevent adhesion of the tablet material to the surface of dies and punches. Adhesion means sticking. Now here adhesion means if it is sticking to different material, like for example tablet is sticking to die wall or punches, it will prevent that. So we call it as anti-adherent. Glidant means whenever hopper will be there in the tablet machine, or hopper will be there, so the flow has to be proper. If flow is not good, then there will be variation in the tablet. So to improve the flow, why the flow is not good? For example, two particles are there, this we call it as interparticle. So to reduce the friction between these two particles, we are adding glidant. So that is the difference between lubricant and glidant. Lubricant is for the ejection of tablet. Glidant is to improve the flow. They will reduce the friction between two particles. Coloring agents. So colorants are obtained as in the dye form or the lakes form. Lakes are nothing but dyes only, but they are adsorbed dye. They are adsorbed on certain adsorbent. And sweetening agent, they provide some sweetness to the tablet if drug is having certain bitterness. The sweetening agent commonly used in chewable tablet. Now if you see carefully, sucrose is also sweetening agent, honey is also there, mannitol is also there, saccharin is also there. But apart from that, in the chewable tablets we are adding mannitol. Okay, we are adding mannitol. So sweetening agent, their sweetness is compared with the sugar. So you have to remember how many times it is sweeter and whether it is carcinogenic or non-carcinogenic. So cyclamate, it is carcinogenic. You can remember it as CC. So it is 70 times sweeter than sugar. Mannitol, it is 72 times sweeter than sugar and it is used in chewable tablets. We have aspartame, which is non-carcinogenic and it is 200 times sweeter than sugar. Then we have ace sulfam potassium, that is 200 times sweeter than sugar. So aspartame and ace sulfam potassium, so that is 200 times. Both are 200 times. Saccharin is carcinogenic and that is 500 times sweeter. Saccharin, it is carcinogenic 500 times. Sucralose, non-caloric, that is it is not having any calorie, so it is a 600 times sweeter than sucrose. Neotame, so that is non-caloric and 7,000 to 13,000 times sweeter than sugar. So it is already in a increasing order, right from 70, then 72, then you have 200, 500, 600, 7,000 like that. So remember all of these sweetening agent. Next MCQ, during the formulation of tablet, the purpose of adding magnesium stearate. Now we have seen certain excipient for the tablet. So can you guess what should be the answer for magnesium stearate acting as what? Okay, so let's see what are the examples. So A is lubricant, B is binding agent, C is adsorbing agent, and D is disintegrating agent. So magnesium stearate, then you have stearic acid or calcium stearate, they act as your lubricant. That means they will reduce the friction between the dye wall and the tablet. So they will facilitate the ejection of the tablet from the dye wall. So that is nothing but your lubricant. Lubricant anti-adherence glidants. Lubricants will reduce friction between the walls of the tablet and the walls of the dye. So ejection of the tablet will be easy. So magnesium stearate, it is frequently used as lubricant. Magnesium stearate is capable of forming films on other tablet excipients during prolonged mixing, leading to a prolonged drug liberation time, decrease in hardness, and increase in disintegration time. So there are certain disadvantages also. That is the reason, because it increased disintegration time, we are using it in a lesser concentration. So what are the insoluble lubricants and what are the soluble lubricants? So insoluble are stearates, which comes your sodium stearate, calcium stearate and magnesium stearate. Then we have talc, glyceryl dibenate and liquid paraffin. So these are your insoluble lubricants. Soluble are polyethylene glycol, PEG 4000 or PEG 6000, and the brand name is Macrogol or Carbovax. So polyethylene glycol, their brand name is Macrogol or Carbovax. Every excipient has their own brand name. And apart from that, we have sodium benzoate, sodium oleate and sodium acetate. So these are the soluble lubricants. The ratio of dry glycerin to dry gelatin in soft gelatin capsule is. So the composition of dry glycerin, that is soft gelatin capsule, is dry glycerin act as your plasticizer. Dry glycerin act as your plasticizer. Now plasticizer will give the softness or it will give the flexibility to the soft gelatin capsule. So higher the concentration of plasticizer, more will be the flexibility. So, and it is the ratio of dry glycerin to dry gelatin. So higher the ratio, higher will be the flexibility. So in the case of hard gelatin, the ratio is 0.4 is to 1 in the case of hard gelatin. Then in case of medium, it is 0.6 is to 1, and in the case of soft, it is 0.8 is to 1. So 1 divided by 0.4 is not the answer. 0.6 by 1 is not the answer. 1 divided by zero point 0.8 is not, because zero point 0.8 is for the glycerin, but they have given in the denominator. So like this also you have to be careful. So option D, that is zero point 0.8, which is glycerin, and 1 is your gelatin. So zero point 0.8 is to 1 is the right answer. So here you can see 0.4 is to 1 for hard gelatin, 0.6 is to 1 for medium, 0.8 is to 1 for the soft gelatin. 000 size capsule can fill the volume of. Now 000 is the largest size. Although the numerical value is less, but 000 is the largest. 000 is the largest and 5 is the smallest. In between also you have. So if you see the option 1.35 ml, that is largest. So 000 can occupy largest volume of 1.35 ml. So A is the right answer. 0.13, no, it is not the right. In fact, that is the smaller one. 0.95, 0.25. So option A is the right answer. That is 1.35 ml. 1.35 ml is the right answer. Then the next MCQ, okay, the explanation is given here, 000, so approximate volume in ml is 1.35 ml and approximate weight. This weight depends upon the density of the material, okay. But considering that it is having 1 gram per cc cube, so it is 950 mg. It is 950. Size 00, that is 0.95, it is 650 mg. Size 00, which is having 650 mg. The size 0, it is 0.75 ml, which is 450 mg. And size 1 is 0.5. So basically you can remember it is half of this, approximately half of this. 1 0.5. So it is 300. And this is 3 you can remember. 3 is 0.3 ml. So that is 200. Size 2 is 0.4 and 4 is 0.25. 5 is 0.15. So based upon the sizes of the capsule, there are different volumes and different weights. But at least remember the volumes, like 1, the half of 1 is 0.5. Then 3 is 0.3 only. Just you have to divide by 0.1. Which instructions are required on the labels of the powder for dusting powders? So depending upon like specific dosage form, some instructions you might have seen, like protect from light, shake well before use. So there is certain reason behind it. So we are using shake well before use for suspension because that gets settled. So dusting powder for internal use, no, dusting powder is not for the internal use, that is for the external use. So we have to give instruction that this is only for the external use. Any infection or anything happens, we are using dusting powder. Shake well, as I said, here it is not required because it is already in a powder form. If it is your suspension, we can write it down, shake well before use. So option B is the right answer. The instruction should be for dusting powders like for external use only. Dusting powders are used on the skin to treat, prevent conditions like rashes, any irritations, moisture buildup, anything. So moisture buildup means that powder will absorb the excess of the moisture. They are indicated only for the external use, and it ensures that users understand the product is meant to be applied to the skin and they has not to be consumed. So this is the dusting powder 5 gram. So we will use purified talc, starch, zinc oxide. It will act as protective, antiseptic dusting powder for external use only and store in well closed sifter top container. And these are some of the instructions. And then here the information regarding its manufacturing and expiry is given. So dusting powder should be for the external use, like on the skin, topical. The solid unit dosage form of medicament in which drug is enclosed in a testless sheet known as. So option A is packets, option B is sachets, option C is antacid, option D is laxative. So the unit dosage forms, okay, these are the categories, these are not the dosage forms, option C and D, okay. They is like a, what action they will show, right? So catechets is the right answer. So they are a type of solid dosage form used for administering the medication, and they consist of thin tasteless shell. So shell should not have any taste. So in this case, if drug is having some bitter taste, that can be enclosed into this tasteless shell, or it is also known as envelope, and it is made from gelatin or a similar material. Inside the catechets, the API, that is your drug molecule, active pharmaceutical ingredient, it is enclosed in a powder or a granular form. So depending, just we have to make a powder or a granule, and then we can give it to the patient. The last MCQ is elixirs is which contains volatile compound. Which of the elixir contains volatile compound? Medicated elixirs, non-medicated elixirs, or aromatic elixirs. Now we know that aromatic elixirs, aromatic means what? Some aroma will come, right? And that has to be volatile in nature. If that is volatile, then only the aroma will come, right? So the correct option is option C, that is aromatic elixirs. So it can be categorized into different types, which is based upon their composition and intended use. So first is medicated elixirs. These elixir contains API for therapeutic purpose. Medicated, the name itself suggests that they are meant for some therapeutic activity, okay. Whereas non-medicated means what? They will not be used as a therapeutic, but it will act as a vehicle for the medicated elixirs. They will act as a vehicle for medicated. And the medicated, it is used to deliver the medication in a pleasant tasting liquid form. Non-medicated, they do not contain API, they do not have therapeutic activity, but they will used as a solvent properties or a base for compounding other medication. Aromatic elixir contains volatile compounds, and the volatile compounds generally are essential oils like cinnamon and all, which will have this fragrant substance, and the presence of this volatile compound will have some distinct aroma and flavor. First of all, elixirs are nothing but your hydroalcoholic solutions, okay. Elixirs, here I'll write, it is a hydroalcoholic solution. It is a hydroalcoholic solutions in which water molecule will be there and the alcoholic part will be there. So that was all about the important MCQs related to the pharmaceutics. So we will see the next model paper and the MCQs in the upcoming session. So thank you so much.